All right, here we go. Page 3, almost done. All right, determine if the triangles are congruent. If yes, state the method and write a congruency statement. Okay, so the way we did this was we picked one of our triangles and we labeled what it was. This thing right here represents an angle. This little tick mark here represents a side. I don't have any more markings on our triangle. Remember, we only look at one. So once we use up all of our markings, we're going to look and see how those triangles are touching. So we have two choices. They're either touching like this, where they share a side, or they're touching like this, where they make two angles. Remember this, like this kissing thing, this is an angle here. This is another angle, that little bow tie where they come together. Okay, which is what we have right here. So this is our, whoops, frozen. Okay, sorry about that. So this is our, where they're kissing right here. So this angle is congruent to this angle because these are vertical. So this is a second angle that we have now. Okay, so we got two A's and one S. So I'm going to put the two A's. I'm going to leave a little bit of space, didn't leave very much. So my choice is angle, side angle, like I'm going to put the S right in between here, like it connects those two angles, or I'm going to put it on the outside here if it doesn't connect them. Okay, so when I look here, here are my two angles. Is that side the thing that we just traced? Absolutely, so it goes right in the middle. So this is angle, side angle. And now we're going to write a congruent statement. So I'm going to name this triangle on the left. I'll call it ABC. And that's going to be congruent to triangle something, something, something. All right, we got to match them up. So angle A down here is the one with the single tick mark. So that's going to match up with this one over here, which is E. B is the one that doesn't have anything. So that's going to match with D. And then the vertical angle goes in the middle or last. Okay. All right, 13, they're not touching, so they should give us enough information. These are all sides, so this is side, side, side. Triangle RST. All right, so now I'm going to do RST. So in this order, so if I go from R to S, do you see how I travel down this line that has 3 tick marks? So I need to start at one end, and I'm actually going to start between this single tick mark and the 3 tick marks. So here's my single and 3. So I'm going to start at Y. I'm going to travel down the 3 to W, and then my last one will be X. Okay, 16. Let's see what we got. We got an S, S, and an A. So I got 2 S's. Is this angle in between the two sides? So if I trace these two sides, do they meet at that angle that's marked? No. So this goes on the outside. It makes a bad word. Okay? The only way this works is if this becomes RHL. Can we change this to RHL? Is this a right angle? Is that a right angle? No, because the symbol for right angle is the little box thing, right? This is a right angle, has that little 90 degree, like the little chair in it. So this is not RHL. This is not congruent. This is nothing. And since it's not congruent, we don't have to write the congruent statement. Okay, 17. Got a little side right there. We got a little curvy thing right there. That's an angle. I don't want to mark these because that's the other triangle. So the only other thing is, how are these two triangles touching? Are they touching like this, or are they touching like this? This is a shared side, so we got another S. So this time we have 2 S's. Is the angle right in the middle? If you trace the two sides, is that angle right in the middle connecting those? It sure is. So this is side, angle, side. So I'll name the top triangle WXZ and do the bottom one the same way. So if I start up here at W and go towards X, that goes down that single tick mark. So that's going to be from Y to X, and then we'll go over to Z. All right. Proofs. Okay, the only proof you have to do is you have to fill in like some missing spaces. So the proof is almost completely filled in for you. And then there are just a couple blanks. Excuse me. All right, so we're going to start with our first given. Actually, they put both givens on the same line. Shame on them, but whatever. Okay, so let's go to our picture. QS, this thing right here, bisects PSR. So this big angle gets cut into two smaller angles. So that's what should be on the next line. QSP, which is this angle on the left, is congruent to QSR. Okay, because that's the definition of angle bisector. An angle bisector cuts an angle into two equal pieces. So that gives us one angle. Okay. Oh, they had this other angle that was given. I hate that they wrote on the same line. QPS is this angle way out here. QRS way out there. So that's another angle. And then there's no more givens. There's no more stuff. So we look at how the two triangles are touching. They touch right here at QS. QS is congruent to itself by the reflexive property. So that gives us a side. So we have two A's and one S. So the question is, in order for our two triangles to be congruent, remember this always goes on the last line, okay? So we got two angles and one side. Is this side connecting the two angles? Is the side going back and forth between the two angles that we have marked? No. So this is angle, angle, side. Okay. All right. Notice that the word prove is nowhere in anything that we write. Ever, ever, ever. Please don't write the word prove here. If that's listed as an answer choice, it'll be wrong. Never, never, never. All right, 19. We're given E is the midpoint of CG and DF, so that's given. We are trying to prove that these two triangles are congruent. Okay, midpoint. What does midpoint tell us? E is the middle of C and G. So if this is the middle, if I were to chop or cut right here, I'm going to cut this segment into two equal pieces. So these sides, CE and EF, are going to be congruent, or sorry, CE and EG, which is this piece right here. Okay. They also tell us that DE is the midpoint, or E is the midpoint of DF, which means that this piece is cut in half as well. So that gives us a second side. Those are both by definition of midpoint. That's why they put them on the same line. Don't really like that they do that, but whatever. So that gives us two sides. We don't have any more givens, so we look at how our two triangles are touching. These triangles are kissing, so we have these vertical angles right here, and vertical angles are always congruent. Vertical angles congruent. Okay, so that gives us two sides and one angle. So when we look at our picture, the angle is in the middle connecting the two sides. So if you trace the two sides, they meet right there at that vertical angle. So side, angle, side. Again, you don't have to write and fill in a whole proof. It's going to be multiple choice. You just got to find the pieces that are missing. All right. Last thing is our transformations. Okay, so the rules are up here at the top, which is nice. It gives us the definition or kind of an idea. Reflection is flipping. Translate is sliding. Rotating is turning. These are our rules for that. It's counterclockwise. And then dilation is getting bigger or smaller. Scale factor is always new divided by old. Okay, to figure out the scale factor. All right, so number 25, we're going to reflect this across x equals 3. It's a little hard to see. This is the x and the y axis. Okay, so if I want to put my pen on x is 3, I'm going to change colors. Okay, I'm going to put my pen on x is 3. So that's right here. So I'm going to draw a line that goes through that point. If I draw my lines left to right, do you see how that's the x-axis? They would just say reflect across the x-axis, so we don't want that. We want a line where every single x value is 3. So this line is going to be a vertical line. This line is x equals 3, going up and down right there. Okay, so we're going to reflect, we're going to flip this triangle over that line. Okay, and just so you know, you're only going to have to do one point. Okay, so let's say we picked I. If we want I to jump over this line that we have colored in right here, it is currently one space to the right of that line. So we need to move it one space to the left of that line, and that's going to be I prime. So that would be at positive 2, negative 1, 2, 3, 4, 5. Positive 2, negative 5. Okay, remember we always start at the origin when we do our counting. Left to right first, up and down second. This is positive x's, negative x's, positive y's, negative y's. Okay, as you move those directions. Okay, so let's do the same thing for h. I'm going to put my pen on h, and then I'm going to start counting. This is 0, and then we're going to start 1, 2, 3, 4, 5. We're at the line, so now we move 5 more. 1, 2, 3, 4, 5. H prime. Okay, 5 to the line, right? Move 5 more on the other side, or something like that, so you remember what we did, right? Okay, so what's that? Here's our origin. So we're going to go 2 to the left, negative 2 x's, up 1, negative 2, up 1. Okay. G is 2 from the line, 2 from the line. That's 1, 4. Okay. 26, this is a translation. I know that because this is adding plus or minus. That means we're sliding the picture. Okay, so we're going to slide 7 x's. So x plus is again to the right. Y plus is up, y minus is down, x minus is to the left. So we're going to go 7 spaces to the right, 1, 2, 3, 4, 5, 6, 7, and then minus 3 is down, 1, 2, 3. Okay, so this was plus 7, and then minus 3. So the origin is right here at the middle. Okay. So from there to get over to here, 1, 2, 3, 4, 5, 6. 6, 0. That's t prime, 6, 0. Okay, and you can do the same thing for each of those points. 7 to the right, 1, 2, 3, 4, 5, 6, 7, down 3, 1, 2, 3. So that's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 5, negative 7. Okay, I'm not going to do the other ones. I'm ready to be done. Okay. Well, actually, let me take that back. The other way you could do that is you could just take your point S and say S is at 1, 2, 3, 4, 5, 6, negative 6, 2. And now you're going to add 7 to your x's. Negative 6 plus 7 makes positive 1. And you're going to take away 3 from your y value. 2 take away 3 is negative 1. So S prime would be positive 1, negative 1. This would be your point for S prime. You could do it that way if you wanted to, instead of using the grid. Okay. All right. 90 degrees counterclockwise about the origin. So counterclockwise is this way. Remember, every 90-degree turn is going to jump it into one quadrant. So our picture is going to be sitting here in the second quadrant. Okay, we're going to use our rule up here at the top for rotation. It says x comma y becomes negative y comma x. Okay, so let's do J. J was at positive 1, 1, 2, 3, 4. Positive 1, 4. So we're going to switch this, and we're going to bring the y up to the front, but we're going to change the sign on it. So if it was a positive 4, we're going to make it a negative 4. The x value goes to the back. Whatever it was, it stays the same. Okay, remember, this doesn't mean that this is always positive and this is always negative. This means we're going to change the sign from whatever it was. If it was negative, we're going to change it to positive. Okay, this y means stays exactly the same, does not change. So this was j prime is negative 4, comma 1. And you can do the same thing for each of those. Let's do one more. M is at 1, 2, 3, 4, comma 2. So I'm going to do negative y. It was positive 2. That's going to change to negative 2. And the x value stays the same. It just moves to the back 4. Okay. All right. 29, dilate using a scale factor of 1/3. All right, so we're just going to count our points. Here's our origin right here. So we're starting. So these are all going to be negative, negative. So we're going to go 1, 2, 3. So C is at negative 3, comma 1, 2, 3, 4, 5, 6, negative 6. So we're going to multiply those by 1/3. Multiply by 1/3. So negative 3 times 1/3 makes negative 1. Negative 6 times, oops, not divide by, times 1/3 makes negative 2. So we did negative 3 times 1/3 and negative 6 times 1/3. And we got negative 1, negative 2. Okay, let's do B. B is at 1, 2, 3, 4, 5, 6, 7, 8, 9. B is at negative 9, comma 0. So negative 9 times 1/3. And 0 times 1/3, negative 3, comma 0. All right, last is symmetry. Line symmetry is if you drew a line down the middle, could you fold this? This wouldn't work because this part sticks way out and this one kind of comes in, so these would not match up. This has no line symmetry. This one does. This has line symmetry right through the middle, going this way. So this has 2 line. This has 0 line. This has 1 line. And this has 1, 2, 3. Okay. And then rotation, I didn't bring any patty paper home. Sorry, I'm getting tired, y'all. So if I sketch this on patty paper and I wanted to rotate it, like imagine that I hold my finger right here and I'm just going to turn this picture. If I turn this 90 degrees, is that picture the same as what I started with? No, but if I flip it upside down, it's the same. So this point here would come over to here and they would match up. So I could turn it one time like that, and then I could turn it a second time. So this has 2 rotational turns, 2 turns for rotational symmetry, which means how far are we going to turn our picture? All the way around is 360. So when you do rotational, you're going to divide 360 divided by the number of turns, and that's going to give you your angle. So right here, 360 divided by 2 is 180 degree rotational symmetry. Okay, this one is going to have 2 as well. This is not going to match to here. If I put this point right here, that doesn't match up, but if I bring it all the way over here, it will, and it'll come back. So this is 180 degrees again. Can I turn this W so that it's sitting on itself? Ever? Is it ever a W? No, this is an M. That's a different letter of the alphabet. So this has 0 turns. No turns. What about this one? 3, 1, 2, 3. If I turn it like this, it's still the same picture, right? So 3 turns, which means 360 divided by 3 is 120 degree rotational symmetry. Okay. All right. One last time. Thank you so much for writing this down. Go back and work the problems again. The more practice you give before final exam time, the better off your grade is going to be. Okay? Love you. Bye.